Everyone, we are going to discuss about aromaticity. Now, aromaticity came from the benzene. Benzene is an aromatic compound. It has a special aroma in it, or the benzene containing compounds may also be aromatic. So, based on that, whether an aromatic compound contain a benzene ring in it or not, the aromatic compounds may be of two types. They may be benzenoid or they may be non-benzenoid. Now, what are these benzenoid compounds? Benzenoid aromatic compounds which contain benzene ring in them, like benzene ring itself, or it may be naphthalene. It may be naphthalene. All of us are well aware about the smell of naphthalene balls. Then it may be anthracene, it may be toluene. So, what I'm trying to say, the compounds which contain benzene ring in them are aromatic in nature, and we call them as benzenoid aromatic compound. Now, what about the non-benzenoid compound? The compounds which do not contain benzene ring in them but aromatic are, like if we talk about this compound, this is cyclopentadienyl. Cyclopentadienyl anion. This is aromatic but not containing any benzene ring. So that is how we can have the benzenoid aromatic compound, we can have non-benzenoid aromatic compound. Now, how do we decide the compound is aromatic or non-aromatic? It is decided on the basis of certain criteria. Now, what are those characteristics to be followed by a compound to be an aromatic compound? Characteristics should be possessed by the aromatic compound. What are these? Like number one, the compound should be planar. It should be planar. All the atoms should be in the same plane. Then, second condition is that there should be a complete delocalization of electron. There should be a complete delocalization of electrons. Then we say the compound is aromatic. Then next condition is the compound must contain 4n plus 2 pi electrons in the ring. The compound must contain 4n plus 2 pi electron in the ring, and this particular rule is also called as Huckles rule. This is also called as Huckles rule, or this is also named as 4n plus 2 rule. Now, what is this n stands for? N is an integer. It may be, its value may be 0, 1, 2, etc. Let's start with, say, if n is equal to 0, then what will be the 4n plus 2 pi electron? 4 into 0 plus 2 pi electron. So there should be 2 pi electrons in the system. Or say if n is equal to 1, then 4 into 1 plus 2 pi electron, going to be 6 pi electron in the ring. If n is equal to 2, then it is going to be 4 into 2 plus 2 pi, that is 8 pi electrons in the ring. So these are the conditions in the compound to be an aromatic compound, that should possess 4n plus 2 pi electrons. Now let's do the examples. Now say for example, we have benzene ring. Now let's take benzene ring. Now here all the carbon, this is sp2 hybridized because double bond. Then this is sp2 hybridized because double bond, again sp2 hybridized. So what I'm trying to say, all the 6 carbons are sp2 hybridized. This molecule is planar. So the molecule is planar, and if I see the number of pi electrons, the number of pi electrons is one pair, another pair, another pair. So going to be 6 pi electron. So here you can see that it follows the 4n plus 2 rule, right? So that is how the molecule is going to be, and the complete delocalization of electron is there. Calculus structure tells us that the pi pair of electron is not localized between any two carbon, while it is delocalized over all the 6 carbons. So complete delocalization of pi electron is also there. So that is why this is what? This is an aromatic compound. Now, let's do the example of naphthalene. In naphthalene also, all the carbons are sp2 hybridized. So that is how the molecule is planar. And the number of pi electrons is, how many pi electrons are there? We can see there are 5 pi bonds. So the number of pi electrons will be 10. So there are 10 pi electrons, and that is how this also follows the 4n plus 2 rule. This also follows the 4n plus 2 rule, and that's how this is again an aromatic compound, naphthalene. Now let's take another example. So these are the benzenoid compound. Now let's identify the non-benzenoid. Say for example, I have this compound. This is cyclopropane. Now if I write a double bond here, it becomes cyclopropene. If I write a positive charge here, then it becomes cyclopropenyl cation. Cyclopropenyl cation. Now, is it aromatic? Let's see the condition. Now here sp2 hybridized, and this is again the planar carbon, right? So that is how the molecule is, or the ion, the species is planar. This is a planar species, and if we see the number of pi electrons here, it is 2 pi electron. So because it also follows the condition, all the three conditions are satisfied. That is why this is again an aromatic compound. But what if I take this exactly of the same type, cyclopropene anion? If it is anion, cyclopropenyl anion, if I take this species, cyclopropenyl anion, now is it aromatic? Now here if we see, the molecule is planar, but what about the number of pi electrons? The number of electrons which will be delocalized are 4 electrons. So that is how it is not following the 4n plus 2 rule. That is why it is not an aromatic compound. It is what? It is anti-aromatic, or it is not aromatic, you may write. Now let's take another example to see this. Say for example, we have this compound. This is cyclopentadiene. Cyclopentadiene, and say we have the pair of electron present here. So that's how, what is the name of this species? This is cyclopentadienyl anion. Now is it aromatic? If we see the hybridization first of all, or the planarity, then we find it like one sp2 sp2 sp2, and this is again planar, right? So this is a planar molecule. It satisfies the condition, it is planar. Now let's talk about the delocalization of pi electrons. Here one pair, another pair, and this is one more pair. So all these 6 pairs are all these 6 electrons are delocalized. So that is how it is what? It is the it is following the Huckles rule, and that's how it is again an aromatic compound. While if we take this species, say for example, it is like this. It is again cyclopentadiene. If I write a positive charge here, now is it aromatic? The name of this is cyclopentadienyl cation. Is it aromatic? The structure is planar, no doubt. Now, what about the number of pi electrons? Number of pi electrons is only 4 pi electrons. That is why it is not aromatic. So, that's how we can see whether the compound is aromatic or not. One more example we may take. Say, for example, we have this species. So, here, how many carbons? 1, double bond here, another double bond here, another double bond here. It is 7 carbon. It is cycloheptatriene. cycloheptatriene, and here is the positive charge present. Cycloheptatrienyl cation, trienyl cation. Now, is it aromatic? If we see the aromaticity, now because this carbon is carrying a positive charge and rest all are sp2 hybridized, so that is why the molecule is planar, so it satisfies the first condition. It's the delocalization of electron is also there. Then what about the pi electrons? How many pi electrons are here? Here 6 pi electrons, so that is why this compound should be aromatic. But if I take cycloheptatrienyl anion, then how is it going to be? Say for example, it is like this. 7 carbon, double bond, double bond, double bond, and here is a pair of electron present. Now, is it aromatic? We have to see. This is a planar molecule, no doubt in that, so it is planar. Now, what about the number of electrons delocalized here? It is 8 pi electrons. How 8? Because 6 because of the double bonds, and one pair of electron is present, so 8 pi electrons are delocalized. That is why it is not satisfying the 4n plus 2 rule, and that is why it is not aromatic. So this is how we can identify whether the compound is aromatic or not. So what type of questions are generally possible here? From this particular topic, we may get the list of compounds, like you are given the list of compounds, say maybe it is like this. You are given the list of compounds and you are supposed to identify whether the compound is aromatic or it is non-aromatic, or if it is non-aromatic, why is it non-aromatic? So this type of questions can be there. Identify the aromatic or non-aromatic compound, or the question can be like this. Identification it can be, and reasons specify for being aromatic or non-aromatic. Now the second is define Huckles rule. What is Huckles rule, or what is 4n plus 2 rule? This is another way of asking question. Now there is a question given in the NCERT exercise also based on the same topic, that is question number 12. Now, what is this question number 12 from NCERT? What this question state, here we are given the various compounds, like one compound is this, and it is being asked, it is being told to us the compound is not aromatic, and we are supposed to tell why the compound is not aromatic. So the compound is not aromatic because here we have a non-planar carbon. This is a non-planar carbon, that is why the compound is not aromatic. Now there is another compound given, that is cyclopentadiene. This is again not aromatic. Why is it not aromatic? Because here the 4n plus 2 rule is not followed, because we have only 4 pi electrons, so the rule is not followed. Huckles rule is not followed. Then we have octatetraene. So what is this octatetraene? It is like this. Like this, 1, 2, 3, 4. So these are the bonds given. So cyclooctatetraene. So this is again not aromatic. Why is it so? Because it is not following the, there are how many pi electrons? There are 8 pi electrons. So that is why again not following the Huckles rule. So that is how the compound is going to be not aromatic, or it's not aromatic compound. So this type of questions can be there from this particular topic. Thank you.